We are looking at an automotive diesel exhaust system. It features an oxidation converter, diesel particulate filter, an NO adsorptive converter, an H2S converter, and exhaust gas recirculation. Moving rearward from the engine, we see the oxidation catalytic converter and the diesel particulate filter in the same container. After that, the NO adsorptive catalytic converter, then the H2S catalytic converter. Two heated oxygen sensors are used, one at the inlet of the oxidation catalyst and one at the outlet of the NO adsorptive catalyst. An exhaust pressure sensor is used, and additionally, 3 exhaust gas temperature sensors are used. An exhaust throttle valve meters exhaust flow under some conditions, and an inlet throttle valve meters inlet flow. Let's look more closely at the oxidation catalyst and diesel particulate filter. It's mounted vertically behind the engine. This is the top view, looking down behind the engine. This is the bottom view, looking up from behind the engine. In the oxidation catalyst, hydrocarbons and carbon monoxide are converted into carbon dioxide and water. The diesel particulate filter, or DPF, filters particulate matter, or carbon particles, from the exhaust flow. The accumulation of this particulate matter could restrict exhaust flow and eventually plug the DPF. So, the DPF must go through a regeneration to clear out the accumulated carbon. During engine warm-up, the engine control module will introduce post-injection, or late fuel injection, to bring the oxidation catalyst and DPF to operating temperature quickly. If the vehicle is driven at high speeds and loads, passive regeneration can occur. It requires an exhaust gas temperature of 350 to 500 degrees Celsius. During passive regeneration, soot particles are continuously burned. For vehicles that spend a lot of time at lower speeds and loads, exhaust gas temperature is too low for passive regen, and soot will accumulate in that filter. When a specific soot load is reached, the particles are burned off at an exhaust gas temperature of 550 to 650 degrees Celsius. Soot load in the diesel particulate filter is calculated by the engine control module. This is based on signals from the exhaust gas temperature sensors, the heated oxygen sensors, the exhaust pressure sensor, and the mass airflow sensor. Additionally, the engine control module will use distance traveled without regeneration as a criteria. For example, between 750 and 1,000 kilometers traveled without regeneration will trigger active regen. Post-injection raises combustion temperature and exhaust gas temperature to aid in active regeneration. Also, EGR will be inhibited, and the engine control module will use the intake throttle to meter airflow. If active regeneration can't be achieved, eventually a regeneration drive will be required. The DPF indicator lamp will illuminate on the dash, prompting the driver to perform a regeneration drive. The vehicle is driven for a short period at increased speeds to ensure adequately high exhaust gas temperature, and the operating conditions will have to remain relatively constant. If DPF soot load reaches 40 grams, a service regeneration will be required. This is activated with a scan tool. The DPF and glow plug indicator lamps will be illuminated simultaneously to warn the driver of this condition. However, service regeneration will be unavailable if soot load exceeds 45 grams. If that happens, the filter must be replaced. The NO adsorptive catalytic converter is located downstream from the DPF. During normal engine operation, oxides of nitrogen are stored on the catalyst surface. Periodically, regeneration or denox mode will be required. This will occur during temporary rich operation. The oxides of nitrogen will be converted into nitrogen, carbon dioxide, and water. The upstream oxygen sensor is monitored to achieve the right oxygen level in the system. The post-converter oxygen sensor is also monitored, and changes in the downstream oxygen level will signal completion. The frequency will depend on operating conditions, but an example might be 12 times per 1,000 kilometers. The H2S or hydrogen sulfide converter is located downstream. Sulfur that naturally occurs in diesel fuel can cause a potential buildup of sulfate in the NO-adsorptive converter, so it goes through a regeneration called desox mode. A byproduct of this mode is hydrogen sulfide or H2S. It's very poisonous, produces a foul rotten egg odor, it's highly flammable and explosive. H2S or hydrogen sulfide is converted into SO2 or sulfur dioxide by the converter. Exhaust emission control is complete, and the remaining gases continue on to the muffler.